this episode for college algebra, we're going to talk about the algebra of functions. There's a few that we need to talk about. We need to talk about how we can add functions, find the difference of functions, product of functions, and the quotient. So let's say we have two functions, f and g. They could be any letter of the alphabet too, but they're two functions that have overlapping domains, meaning that we're going to find the union of their domains. Then for all x common to both domains, the sum, difference, product, and quotient of f and g are as defined. So if I'm finding the sum of two functions listed as f plus g of x, I can add the function f of x with the function g of x. To find the difference, I can take f of x minus g of x. To find the product, f of x times g of x. And to find the quotient, I can divide them, keeping in mind that g of x, our denominator, cannot be 0 because we know we cannot divide by 0. So let's say that we have two functions, f and g. We have f of x is equal to x plus 1, and g of x is the function, the square root of x plus 3. Let's add these two functions together. So to add those two functions together, I'll take my f of x, which is x plus 1, and add it to g of x, which is the square root of x plus 3. Since they don't have any commonalities between them, we can't add them together because there's no like terms. Now that I've found f plus g, I can then evaluate at the function f of 6 plus g of 6 by simply plugging in 6 where I see my x values in my simplified function above. So 6 plus 1 plus the square root of 6 plus 3. That will give me 6 plus the square root of 9, and we know the square root of 9 is 3, and 7 plus 3 is 10. Let's look at f plus g of negative 4. So I've already found my f plus g of function, which was the x plus 1 plus the square root of x plus 3. Well, I know that my domain of f is all real numbers from negative infinity to positive infinity because we know it's a linear equation. However, the domain of our g of x function is slightly different. If we were to graph this, our graph would not go past any more negative than negative 3 because we know we can't take the square root of a negative number. So what we did was say that x plus 3 on the inside of a radical had to be greater than or equal to 0. That tells me then that my domain of my g function is x has to be greater than negative 3. I certainly could evaluate my f function at negative 4. However, I won't be able to evaluate my g function at negative 4 because it doesn't exist. And since one of them doesn't exist, we cannot find the sum of these two functions together. So we would simply say that it does not exist. If f and g are functions, then the domain, when we add, subtract, or multiply, is the intersection of their domain. And the domain of f divided by g is also the intersection with the exclusion of any values of which the denominator is 0. So we'll exclude any value which the denominator is 0 in that case. If you're struggling to identify what the domains are, I highly recommend graphing them individually or graphing the finalized product of the addition, the subtraction, or the multiplication to help you. Let's say we have two functions. F of x is x squared minus 4 and g of x is x plus 2. Let's find the domain of f plus g, f minus g, f of g, and f divided by g. We know that the domain in our x squared minus 4 equation is all real numbers because it's a quadratic. So it's going to move left and to the right for all real numbers. The same is true for our linear function x plus 2. So then the domain when we add them together will still be negative infinity to positive infinity. Similarly, when we subtract, we'll still be negative infinity to positive infinity, and as well as f times g will be negative infinity to positive infinity. However, we have to be very careful when we divide because when I take x squared minus 4 over x plus 2, we know that it cannot be defined when x is negative 2 because if I were to replace negative 2 in my denominator, we would end up with a 0 because we cannot divide by 0. Therefore, the domain will be from negative infinity till negative 2. We're going to skip negative 2 and continue to positive infinity. So we're excluding the value of negative 2. So let's go ahead and find some values that's listed. So if I add them together, I'll have x squared minus 4 plus x minus 2. Combining like terms gives us x squared plus x minus 2. Let's subtract them. I have x squared minus 4, and now I'm taking away all of g. So that's why I'm putting g in parentheses, because I have to subtract all of g. So I'm going to subtract x plus 2. I now have to distribute my negative 1, giving us x squared minus 4 minus x minus 2. Combining like terms gives me x squared minus x minus 6. Now multiplying them together, I will have x squared minus 4 times x plus 2. Now that we have our two binomials written, we can go ahead and distribute, giving us x cubed plus 2x squared minus 4x minus 8. We can now work on dividing our two functions, f of x divided by g of x, where we will have x squared minus 4 over x plus 2. I need to factor my numerator before I can simplify. This is a difference of perfect squares. Difference of perfect squares will then give us x plus 2 times x minus 2 over x plus 2. When I cancel out my x plus 2 binomial with my x plus 2 in my denominator, I get that we'll have the function x minus 2, so I can simplify when we need to, and if possible. However, we have to say that x cannot be negative 2, because we already decided that in our domain, x could not be negative 2. We also can do fun things like take g of x times itself in some instances. So if I wanted to find g of x times g of x, that would give us g of x squared, because there's two of them, or x plus 2 squared. I also know that x plus 2 is not x squared plus 4, but rather x plus 2 times itself, x plus 2. Then we'll distribute, simplifying will give us x squared plus 4x plus 4. The final piece that we need to talk about is what we call the difference quotient. It helps us to compute the slope of a secant line through 2 points. Now the secant line, notice, is a line that goes through 2 different points on a curvy type line. This is very important when we move into calculus because we want to know what the instantaneous rate of change is at a given moment. It's called the tangent line. So the formula itself is f of x plus h minus the function divided by h. So if you're deciding to take pre-calc in the spring, this will be one of the most important pieces that we'll learn. So let's first start by taking f of x plus h minus f of x minus 8, or divided by h. We already have our f of x function, but I don't know what f of x plus h is yet. So I need to find what f of x plus h is. So wherever I see x in my function above, I'm going to replace it with x plus h. So f of x plus h is equal to 2 times x plus h minus 3. We'll then need to distribute, giving us 2x plus 2h minus 3. This is now our f of x plus h formula, and we can plug it into the equation. I've got part of it listed here. So 2 times x plus h minus 3 minus our f of x function all over h. We already simplified our f of x plus h to give us 2x plus 2h minus 3, distributing negative to negative 2x plus 3 all over h. You'll notice that we can go ahead and simplify. We can cancel our 2x's out and cancel the negative 3 plus 3, which leaves us with 2h over h, and that can reduce down to 2. I now have the function given by f of x is equal to 1 over x, and simplify the difference quotient. I don't know what f of x plus h is, but I do know that I'm going to replace within my function the x plus h, giving us 1 over x plus h minus the function itself, which is 1 over x over h. I'm going to need to combine like terms in the numerator here, but before I can do that, we need to have a common denominator. Our common denominator is x plus h and x. That means I'm going to multiply the left-hand side by x over x and the right-hand side by x plus h over x plus h. So now each one of our denominators has an x and it has an x plus h. And this will still all be over h. When I multiply my numerators, I'll just have x over x times x plus h, kind of cleaning it up a bit, minus 1 times x plus h gives us x plus h, and then cleaning up our denominator. Now that we have a common denominator, I can go ahead and combine our numerators together. This will give me x minus x plus h. All of this piece, we're taking the entire numerator and subtracting it. All over 1 now, denominator, still all over h. We're going to work on getting rid of this complex fraction here in a moment. I can now distribute my negative through, so I'll have x minus h. I know that my x minus x will end up canceling, so I'm going to be left with negative h in our numerator. And at this point, I'm going to multiply by my reciprocal so that I can get rid of this complex fraction. That gives us negative h over x times x plus h times the reciprocal of h would then be 1 over h. Notice then when I multiply my numerators, my h's will cancel out, and all I have left in my numerator is negative 1 over x times x plus h, or putting the negative out front. And this concludes our lesson for section 2.2.